Now, so linear inequalities, what we are going to cover in today's session under linear inequalities, we'll start by looking at how can we be able to solve linear inequalities in one unknown. How can we be able to graphically represent the linear inequalities that is now in one and in two unknowns. And lastly, we can be able to discuss the applications of linear inequalities, how useful are these kind of concept on linear inequalities in our real life. Then just beginning very fast, we had defined what an inequality is, and it's not something new to us, that this is a range of values and not just a set of number. Okay, so you have a range of values. Now in algebra, you say it's an algebraic relation that is going to show whether a certain quantity or value is greater than or less than another compared value or quantity to it. That's what you need to say. Then I was taking them through the example. Here we have a speed limit. Now, real life, you know, those traffic marshals or police normally look at the speedometers and they say you have exceeded the speed limit. So majorly we have that if the unknown X is our speed limit, then sometimes you'll find that it's supposed to be more than around 50 and 55 for your vehicle to be moving at the required speed, and it should not exceed 80. That's why I've used it can be less or equal to 75. Okay, so that is 55 is less than or equal to the speed limit, and also the speed limit is less than or equal to 75. We shall be able to understand that more. This is just an example to take you back to the meanings in grade 7 that you looked up at. Now, also through the recall, we have symbols. Inequalities are represented using symbols. And there we go. We have 4 of them. I hope once you see them, you can be able to remember what they mean or what they are used to represent. So the first symbol is actually telling us that a quantity is less than. That tells us that a quantity is less than. And then the next one, that is for greater than. Greater than. Then we have the repetition, but now with an underscore. That is supposed to tell us a quantity is less than or equal to. That is for less than or equal to. Then lastly, we have greater than or equal to. So you need to be conversant with these particular symbols. In any case, you will be handling questions on inequalities. Then you see the use of these symbols. And even when you have an algebraic expression that contains these symbols instead of an equal sign, then that becomes a what? An inequality. All right. So let's dive into more. Look at the range of numbers that we have talked about. If I have this, you remember what it is? That's a number line, okay? And that is what you commonly used in grade 7. Now, if you have this number line and pick a point, let's say a point 2, that is a value 2, then you can be able to get certain range of values going to the left from that point 2. Okay, so the red is indicating that we are going to the left from that particular point. From that particular point, going to the left, then it means that if you have those values, you can represent your inequality as being less than 2, because towards the left of the number line, the numbers or the values are smaller. Okay, so they are less than 2. So in other words, the inequality x being less than 2 has been represented on that number line. I want you to notice something, that our circle representation is very open. It has not been shaded. That is what I also want to really insist, that when you are representing using only one symbol, that is less than or greater than, you will only have open circle. Look at another one. In this case, look at another one. These are the number line. Now let's have -2 as our value. Then we decide to move towards that direction. From that part going to the right. And what will be our inequality from this kind of illustration? It simply means that the values that are more than -2, so greater than. So we are going to say that all the real numbers are supposed to have a greater than -2, and that's how we shall represent our inequality. Okay, we shall say the quantity is greater than -2. Why? Because on the number line we've seen it is on the side, on the right hand side of that number line. Good. Moving on also to the last 2 bits, just to insist. This is a recap of what you did in grade 7. Now, look at that. I have identified the first value as 1, but now this value is shaded, and I'm going to compare it to the values that are on the other side. The accepted values are towards your left. So now what do we give as our inequality? The inequality becomes less than or equal to, less than or equal to 1. So we know that because it was shaded. And the last part, this one for greater than. If you pick -3 as your value and you have accepted values going towards the right, okay, you have the accepted value going towards the right on that direction, then it means your inequality becomes greater than or equal to -3. So that's what you present. Up to that point, I hope we are clear. If you have an open representation or box or dot, then it means your inequality contains only the symbol of either less than or the symbol of greater than. All right? And that you decide on moving to the right or on moving to the left. So moving to the left, that means your value or your quantity is less than that particular number. If it is moving to the right, then it means your quantity is greater than that value you are starting from. That is okay. Then if it's shaded, as in this particular manner, then it means it's greater than or equal to or less than or equal to. That is what you need to put in mind. So what do you think? If the symbol is greater or less than, then the dot is supposed to be open because that particular value is not included. Okay? That particular value cannot be equal to the quantity you are representing. But if it is dotted, then it means that particular point or that particular value is also going to be the same as either to represent that your quantity. So it can be that point too. That's what we mean by if it's greater or equal to. So we can either have our quantity being less than 1 or it can be equal to 1. So that's why we include it in our dotted. Have we understood up to that particular point? And us to look at solving inequalities in one unknown. Solving inequalities in one unknown. This is also not new to us, just a repetition. So to solve a linear inequality in one unknown, it's just the same as solving a linear equation, okay, or an algebraic equation in one unknown. It's just the symbols that have been changed from the equal sign now to an inequality symbol. Now, so we normally collect like terms on one side of the equation. At this particular time, now we are dealing with inequality. So we shall be talking about collecting like terms on one side of the inequality symbol. Are you getting that? All right. So look at this. We can be able to solve this inequality. One unknown means the value or the term that we don't know its value is x, right? So that's the unknown. Now, if we want to get the value of x, in this particular aspect, I'm talking of using addition to solve. Why? Because we have -3 that is on the same side with our unknown x. So how can we be able to move this -3 to the same side, to one side with the 5, because it's a like term to 5. So we'll realize that we are going to add it on both sides, and that's why we have solving using addition. So we'll be adding it on both sides. Now that is what happens. You add the same number to each side, and that is the -3. You'll add it on both sides. So x minus 3 plus 3 gives you a 0. Also on the other side, where we have 5, you put plus 3. But the common analogy that you use or you are used to, you just say, I want to shift this -3, to the other side of the inequality symbol. And therefore, when it jumps the inequality symbol, its sign changes. So it changes from the negative to a positive. And therefore, that will give us x is less than 5 plus 3. And you already know what our answer becomes x is less than 8. X is less than 8. Have we seen how we are solving that inequality? Such a case using subtraction. Now, in this case, we have x plus 6 is greater than or equal to 10. X plus 6 is greater than or equal to 10. Now, we need to move the like terms on one side of our inequality symbol, and we can see 6 and 10. We need to put them on one side. So what will happen? We'll take 6 and place it on the other side of the inequality. And because it is +6, when it goes to the other side of the inequality, it becomes a minus. That's why I'm talking about subtracting the same value from both sides. So x plus 6 minus 6, that gives you x plus 0. Then is greater or equal to 10 minus 6. So we'll find our answer to be what? X is greater or equal to 4 because of the 10 minus 6. Plus 5 is greater or equal to 3. What you need to do is find the solution first. So you realize you need to solve this for you to make a simple inequality before you can represent it on the number line. So what you do, you will now use the concept of subtraction, okay? So you'll subtract 5 from both sides. So x plus 5, when 5 goes to the other side, becomes a minus. So you'll have x is greater or equal to 3 minus 5. So 3 minus 5 is actually -2. So what will you do? You will put a dot at this particular point. So your dot is going to be at this particular point here. -2 here. This particular point here. -2. Okay. You'll draw your point there and make sure it is shaded because of the equal to. So -2 can also be part of our solution. Can also be part of our solution. Good. And your values, accepted values, are going to be on which side? On this side. Not the left side, but on the greater side, the right-hand side, because it's supposed to be greater or equal to -2. All right? Good. So now I know you can be able to solve those and represent just by a matter of doing practice. Also, you can be able to check on that. Just a matter of now moving. Which value should we move from this particular point? It's actually the -4. So you'll take -4 to this other side, and it becomes a what? A +4. So it's now saying 4 minus 2 is greater than n. So we shall have 2 is greater than n. And where do we represent it? We shall put this particular value here at this point. We don't shed. You don't shed. So you are just going to Let me use a pen to annotate that. This one. Use a pen here. So we are going to have our point at this particular level. And because it is greater than n, so the accepted values of n will be on this other side. So n is less than 2, okay? N is going to be less than 2. Look at this. How can we be able to solve inequalities by multiplication? Now, by way of multiplication, we have two kind of scenarios. The first scenario is when we multiply each side by the same positive number. That is, a half x is greater than 3. What is the value of x? You realize that you will multiply both sides by what? By the 2. So multiply both sides by the 2 to remain with the value of x alone. So this is what happens. Multiplying by 2, you'll have x is greater than 6. That one will have solved already in that easy manner. But now, there's another case. If you have to solve using division, but now by a positive number, that will still remain. You just divide. Say if you have 3x is less or equal to 9, just divide both sides by the coefficient 3 to remain with the term. So the term is going to be x is less or equal to 3. Just forward. Kama ile ya algebra. Now, look at that. When you are now multiplying inequalities by a negative number, something interesting happens. And this is what happens. Look at an example here. You have the inequality negative x is less than 4. Negative x is less than 4. Then you are asked to solve that inequality. I know you would have said, it's already solved. No. Because we want to get the value of x and not a negative x. What will you do? There is a 1 at this particular point. We take this particular point to be having a coefficient of 1 here. At this particular point, 1. So the coefficient is negative 1. So negative 1x is less than 4. All right? So what we'll say is for us to get x, we need to divide both sides by negative 1. We need to divide both sides by negative 1. And there we go. Apply both sides by negative 1. And we are going to see that when you are multiplying both sides by a negative, it means you are going also to change or to reverse the inequality symbol. If it was less than, you change it to greater than. I want you to look at that very, very keen, because that's the concept now we are introducing in grade 9. We didn't look at that in grade 7 and other grades. So you have to be very keen when you have been told to solve an inequality symbol and it entails the multiplication by a negative number on both sides of the inequality. What you need to do is change that inequality symbol. See, this was negative x is less than 4. Multiply both sides by negative 1, negative 1. Then you'll form a solution which has x. Instead of less, becomes greater than negative 4. Okay? Because the negative reduces the value that you are dealing with. It reduces the value. All right. I hope we are good. We have understood that part. You've said that you can be able to solve inequality by multiplying both sides using negative numbers. So when you use negative numbers, you are supposed to reverse the way the inequality symbol looks like. If it was greater, then you multiply both sides of that inequality with a negative number. It becomes less. Okay? So this is our example that we are using. Negative x is less than 4. Okay? So if you want to get x, only x and not negative x, what do? You simply need to multiply both sides by -1 because x has a coefficient of 1 at this particular point. You just draw it. Here, there is a 1 here. Okay. So now when you are multiplying negatives on both sides of our inequality, you have to change the direction of that inequality. This is less than, then it means changing it will reverse it to become a greater than. Okay. We shall see that also in division. So I know you'll be able to get it. So this was less than, negative x is less than 4. But when we now want to get positive x, it means we multiply both sides by negative. Remember, -1 times -1 gives you positive from integers, the grade 9. And also 4 times -1 gives you -4. And that's why we are saying, because we are multiplied by a negative on both sides, let us change the direction of our inequality symbol from facing the left facing to the right. That is now giving us less than is changing to greater than. All right. Same happens when we are dividing both sides by a negative. Let's look at this example. -2x is less than or equal to 6. -2x is less than or equal to 6. If I want to solve for the value of x, what am I going to do? I am going to divide both sides by -2. Okay, so that happens. Say divide both sides by -2. And when you do that, remember also dividing both sides by negative, you need to interchange the inequality symbol. Need to interchange the inequality symbol. So those are the main two concepts that we are adding on to what we had from grade 7 on solving inequalities involving one unknown. We used to solve them using only addition and subtraction, but now here we are solving them using multiplication and division, and we have moved to integers now. What if you solve by multiplying by negatives on both sides of the inequality symbol? What if you solve using what? Division, but you are now dividing by a negative number on both sides of the inequality symbol. You need to know that I must change. You have to change that particular inequality symbol. And it's easy, just changing from, if it was less, you change it to greater. It reverses. That's what has happened here. You've seen that -2x is less than or equal to 6. When we divide both sides by -2, then we have to say x is greater than or equal to 3. So, good. So that is what we needed to note. That is what we needed to note. And that marks our first half of the lesson.